Hello hackers, welcome back. This is RogueSMG and today let's dive into some more JavaScript. Before we begin, let me tell you that there are a plethora of things that you can do with JavaScript files. And I quite obviously do not know everything, nor do I even try to do everything with the JavaScript files. And even trying to show everything that I know in depth will be out of the scope of this video. So what I'll do is I'll just try to show what are the possible things that you could do with the JavaScript files, what are our objectives, and just a little bit about how actually you can do that particular thing. But of course, if you want some more in-depth view about how to do that particular thing, just let me know in the comments below and I'll try to make a separate dedicated video just for that. With that said, let's get technical. Okay, so being a good obedient child, let's say you fetched all the JavaScript files for a particular target. But what next? What can you actually do with those JavaScript files? And why are we even bothering with fetching all the JavaScript files or getting all the JavaScript files for our target? Well, let's divide it into 4 different objectives. And the first one is increasing the attack surface. And by attack surface, I mean finding some more URLs, finding some more subdomains, finding maybe some internal domains, stuff like that. And I had explained a bit in depth about why actually this happens in the previous video, and I won't try to explain the same thing here. So if you haven't watched it, or if you are confused about why we are finding some unique URLs or subdomains from the JavaScript files, you can check out that video and I'm sure it will clear all your doubts. Now the second thing is sensitive information. The usual, trying to fetch any secret tokens or any API keys or any maybe database credentials, passwords, something like that. Pretty straightforward. And you could use grep for those, or maybe you could try to find out some patterns people have shared over GitHub or Twitter, something like that. So that's the second thing. The third one is, and this is quite important, a bit hard but equally rewarding, trying to understand the code and trying to manually decode everything and understanding the flow about what's actually happening in the web application. Of course, considering that it depends on the JavaScript files for calling its function, or maybe it's a .NET or Java app, something like that. That can lead to some DOM accesses or maybe some post message vulnerabilities and even some pretty serious logical bugs as well. And let me give you an example about the business logic thing. For example, let's say an application is based on .NET or Java and it depends on JavaScript files or jQuery for performing any functions, and consider it as an e-commerce website. So if you had something in your cart, a JavaScript endpoint is called named as start.js, and as you place that order and proceed to the payment phase or maybe try to do your payment, it is calling another JavaScript file named as doing.js. And as your payment is confirmed and when the response is received from the server that the payment is successful, another JavaScript file is being called named as success.js. Now let's try to understand the flow. As you add to the cart, the first JavaScript file which was called is start.js. The second one, when you actually start your transaction or when you actually move to the payments page, another JavaScript file is being called named as doing.js. And finally, when the confirmation is received from the server, the final JavaScript file is being called and which is named as success.js. Now what happens if you try to skip the doing.js and directly try to call success.js? It is quite possible that the whole payment phase is skipped and that item is actually bought or the order is being placed without even making the payment. So that is something you can do, or which you could find in those JavaScript files. And there are some reports as well. People have found such vulnerabilities and I'll try to post the link in the description so you could check that out. And the fourth one is outdated frameworks and components. Well, it's quite possible that the application is using a lot of frameworks and some of that framework is based on JavaScript and it's using an outdated version which already has some CVEs, or maybe it's using some outdated components which has again some CVEs or any CVE vulnerabilities or something like that. So that could also lead to very easy wins just by manually doing some work and looking at the JavaScript files. So these were the 4 basic things or the overall objectives of why we are trying to mess with the JavaScript files and why we are trying to actually get out of those JavaScript files. Okay, so these were just the objectives of why we are trying to fetch those JavaScript files and what are we trying to get out of those JavaScript files. Now let's see some tips and tricks or some techniques of how you can actually do those things, and just some little things that might help you out in your process of messing with the JavaScript files. Let's see. And let me just open up my VPS. These were all the things that we found previously. Now let's imagine we tried to fetch all the URLs from Gau or Wayback Machine, and we are trying to fetch the JavaScript files from there as well. So the command could be something like, let's just say cat webdomains.txt, and web domains have all our live domains which have port 80 or 443 open on them, so they will be having JavaScript files. Now maybe wayback URLs, and we could try to maybe do something like grep. So what it will do is, maybe let's try to run it. I guess it will take some time. Let's see if we get some results. Now what we are basically trying to do is, we are trying to see, we are getting some results. Let's just stop it for now. What we are trying to do is, wayback URLs or Gau, as we discussed in the previous videos, will have all different kinds of URLs, and of course it will have JavaScript URLs as well. So we are trying to fetch all the JavaScript files from Wayback Machine or Gau as well, just to see if we could find any previous JavaScript files or any new JavaScript files as well. But what might happen is, when you try to fetch all the JavaScript files from Wayback Machine, it's a very high probability that that JavaScript file does not even exist now, or the name of that JavaScript file is changed, or it's just not existing anymore. So what we could try to do is, we could try to do something like this. So this is the command. Instead of echo, you could just cat your file containing all the web domains, pipe it through Gau or Wayback, grep all the files which have .js in them, or here we have added a dollar which just says all the files which ends in .js. So any of the file that ends in .js, only those files will be grepped out of all the URLs that Gau finds. And maybe we could just add IE here. Here E means extended grep. So what it means is, like, it just allows us to use regex to find any information from whatever is being piped through it. And I is just for non-case sensitive. Now what we could do is, HTTPX, as we have discussed, is another tool just like HTTProbe to check if port 80 or 443 basically is active there or not, or are we getting any response from the server or not. So what we are trying to do here is, we are trying to pipe it through HTTPX, and we are trying to match the status code with 200, and we are also trying to fetch the content type from the response as well. And then we are again grepping for application/JavaScript. So what actually is happening here, we're trying to fetch all the URLs for our target using Gau, and then we are grepping all the JavaScript files from that, and then we are trying to pass all those JavaScript files and check whether they are alive or not. And if they are alive, they'll have a response code of 200 OK, and if they are alive and actually of type JavaScript, then the content type will be application JSON. Because many times it might happen is, you will get a response of 200 OK, but the server might not have JavaScript files, or it might be showing some custom error on the page but with response 200 OK. So that is the reason we are trying to fetch the content type as well. And finally we are trying to grep by the content type itself. So what it will do is, it will fetch all the JavaScript files which are live and which are actually returning JavaScript itself and nothing else. Well, that's what this one-liner does. So this is something which will help you to further purify or further clean your output, rather than having a lot of garbage, a lot of rubbish, and trying to manually check and figure out if that's working or not. So this is just an easy way, and there are a lot of combinations you could try out just like this one. This was just a very easy way to do this, and I did not come up with it. I maybe found it somewhere, but it was really good. So that is why I wanted to show this here, just as an example of the stuff you could actually do to get a cleaner output from all the garbage that we have collected. Now here there's another example, and what it does is, it just cats a particular JavaScript file and you could provide a file containing all the JavaScript files as well, and it just tries to grab all the things or all the stuff which has /API in them. And this is another one-liner I did not come up with myself, and I have picked it up from somewhere, but this is just to show you as an example of grabbing sensitive information out of those JavaScript files. Now the next thing which I want to tell you about is de-obfuscation. Many a times what happens is JavaScript files are usually minified or obfuscated for efficiency and as just a defense in depth practice. But they are very easy to de-obfuscate, and you can do that easily using some online tools itself. So let's just see. First of all, let's see what an obfuscated JavaScript file might look like. Let's check out some images. So as you can see here, this is an obfuscated JS file, and it's quite difficult for you to understand. Or maybe it's something like this, or maybe something like this. Basically something which does not look like a JavaScript file but is a JavaScript file. Consider that it is most probably obfuscated or minified, and you could easily de-obfuscate that with many online utilities like, let's just see, and there are a lot of sites, de-obfuscate JavaScript or beautifier.io, tcode.fr. So you just do nothing but paste the JavaScript code here, and it will show you an extended or a clean version of that JavaScript file. And let's see if I can show you an example. This is rather much cleaner JavaScript file, but as you can see, as we click de-obfuscate, it cleaned the JavaScript file, it formatted it in a pretty way, and overall it made it more readable for us. So this is something you should consider when trying to manually review the JavaScript files. If they are obfuscated, just try to de-obfuscate them and see what you can find. Now, as we discussed about de-obfuscation, it again gets us to probably the most boring part you and maybe even I hate as an hacker, but there's no workaround for it. Manually looking through all the JavaScript files, or all the potential JavaScript files to be precise. And this is something that you absolutely have to do while all the automated tools do their own work. There is no tool invented which will land you all the things, and the machine where Alu dalo, sona niklega is just a myth, and there's nothing like that. So you will obviously have to manually go through all the JavaScript files if you actually want to get some in-depth knowledge or some good bugs related to your target. And of course, you do not have to go through each and every JavaScript files. If you have thousands of JavaScript files, you do not need to go through all the JavaScript files. You just need to go through specific JavaScript files which are related to your target, and those might be something like main.js or app.js or any such names which you couldn't find out. And as we discussed, if you cannot figure out what are the related JavaScript files, just eliminate the JavaScript files which are not related. For example, if there are any third-party JavaScript files, you will see static / something, or you will see jQuery.something. Basically, you will figure out. Let me just show you if I can. So here we can see legacy of good.del.com, etc design, theme, ghf.mini, something.js. So as you can make out that it's something from the theme folder and something in the design folder, it might not be interesting, or it doesn't sound something which might have a vulnerability. So just skip that and try to find something more specific or sounding juicy. Maybe something like yahoo.com/serviceworker.js seems pretty interesting to me, or something like maybe something like this, gtm.js, or maybe something like this, some yoda container.js. I don't know what that is, but you get an idea. Try to find something which is not common, or try to eliminate the things which seems extremely common. You can do either ways, cause why not? That's one thing which you will have to do manually. And as we discussed before, it helps to find some DOM accesses vulnerabilities, post message vulnerabilities, and to be quite honest and frank, I personally quite suck at DOM accesses or post message vulnerabilities and trying to uncover or decode the code from the JavaScript file, as I'm not from a developer background and I do not quite know how to actually code JavaScript. But even if that's not your thing, you could easily try to look for business logic vulnerabilities as we discussed in the example about start doing and success.js, and you could find very interesting and crazy stuff like that in this JavaScript file looking manually. And for DOM accesses, you could try to use the developer tools in Chrome or Firefox and use the breakpoints to maybe try and see at what point of time what are the variables holding certain values and what is the code. You can just mess around with that and see the whole flow of the application. You should definitely try to look into those, as there are some pretty serious and interesting vulnerabilities which people have found just by messing with developer tools, breakpoints, and nothing else. So definitely check that out. The next thing which could be interesting are relative URLs, paths, or URLs and stuff like that. And we could find those using relative URL extractor or link finder. These are two great tools which I personally know of. There can be some more as well. If you know some other tools, do let me know in the comments down below. But that said, link finder and relative URL extractor are pretty good at what they do, and they help us find some relative URLs, paths, and stuff like that from our JavaScript files. But since we fetch the JavaScript files using JScanner, which is just a wrapper around link finder, we do not need to run link finder again. And what we can actually do with those findings, let's see. As you can see, there are a lot of relative URLs as well, and there is a lot of noise as well. So you'll have to do some manual work to remove the noise from this. And what you could do is, you could of course find some direct bugs using this, or trying to append something like, maybe let's see if there's something interesting, trying to append pattern properties on yahoo.com itself, or whatever the target URL for which you ran link finder. You could directly try to append these endpoints on that particular domain and see if there is any sensitive information disclosure or something like that. And if not, what you could do is, you could try to generate or create a word list using all these paths, and you could try to brute force using this on all of the subdomains that you found for your target. And why this might lead to some bugs, because what might happen sometimes is, a path which is not interesting for maybe abc.com might be interesting for test.abc.com. So for example, let's say -items does not display anything for yahoo.com itself, and we have ran link finder on yahoo.com itself. Here are the results for yahoo.com. But if we try to append /items on maybe demo.yahoo.com, then it might leak some sensitive information. So that is why this is a very good method, or very trivial method to find information disclosures or broken access controls or any post browsing vulnerabilities using just the word list created from these endpoints. So just curate all these endpoints and run it through all your subdomains using FUF or any other tool which you might like for directive brute forcing, and that could lead to pretty good findings and pretty good bugs as well. So definitely check this out and include this in your workflow. And also another thing which you could do is, try to open any particular JavaScript file. Let's see if it has. What you could try to do from here is, this is, as we discussed, the minified JavaScript. You could paste the whole thing into JS beautifier or something like that, and it will give you a very pretty output. And what you could try to do is, if there are any elaborative variable names, you could directly try to append those in the URL and check for XSS or SQL injection in those variables itself. Because what generally happens is, sometimes the variable which are referenced in the JavaScript files or in the source code of the page, they might be any legacy variables, or they might be existing variables which are not expected to be entered as get parameters in the URL itself. So if you try to append them as get parameters, and if you try to maybe perform XSS or SQL injection there is a probability that you might find XSS or SQL injection there. So this is another thing which I wanted to mention, and which you could definitely try out, and it might lead to some pretty good bugs as well. And finally, another thing that you could do here is, if you find any internal host and maybe let's say they are something like internal.yahoo.com or something like that, and if you try to open that, it does not open or it says host not found or something like that, what you could do is you could try to port scan on those internal domains and check if they are running on some non-standard port other than 80 or 443. That way you could very easily find some critical bugs, because those internal domains are usually not expected to be found in the public, because they are neither exposed to the public or never cached by any search engine or anything like that, and thus they are very likely to be not protected or very less protected considering from a security standpoint, as they were never expected to be found on the internet. There's another thing which you could try out. And now the final thing that I want to talk about here is monitoring the changes in JavaScript files. For example, let's say you regularly hunt on a specific target, which you of course should be doing, and even before that, always consider that new code changes and development changes are constantly being updated, and the backend code is constantly being changed and updated, and new updates are being constantly pushed onto the web application, considering the company is large enough. So if you are thinking that this is a very old program and I'll not be able to find bugs, it's not like that. New code is probably being pushed every day. So there might be chances of new vulnerabilities getting into the wild each and every day. It's not like you won't be able to find any bugs. Now that said, you'd want to consider monitoring the changes in those JavaScript files. There are tools to monitor changes in the URLs or source code as well, but here we'll try to see some tool or some techniques by which you could monitor changes to the JavaScript files. So for example, if we select a particular JavaScript file and we want to monitor that JavaScript file itself, if there are any changes being pushed or if the code is being updated in that particular JavaScript file, we'll get notified. And as we are notified, you'd be one of the very early hackers which might be notified for the same thing, or which might even be looking for the same thing. And that way, if there is any critical thing or any critical vulnerability introduced within the code, you'd be one of the first hackers to find that out, and thus it might be a very easy and a very trivial bug for you. That is why we are trying to do all this monitoring stuff, and that is why I'm blabbering right here instead of just showing you. So let's just see that. And the tool which we are seeing here is JSMon. There might be other tools, but JSMon is something that I have heard of, so we'll see that. So what it basically does is, as we discussed, we just need to provide any particular JavaScript file or any particular URL to the JavaScript file, something like into the targets folder. So what test is, let's see. This is nothing but just a simple or a single JavaScript file. What you could probably do is try to provide all the JavaScript files for a single web application into a particular file, or divide the files based on different targets, whatever might suit your needs, and just mention all the links in some file or some folder and move it into the targets folder. So something like that. We have test, and inside test we have a JavaScript file and nothing else. We just need to run Python 3 jsmon.py, and it returns nothing here because there are no changes in the JavaScript file. So if there are any changes in the JavaScript file, for whatever JavaScript files we have mentioned or we have added in the targets list, it will provide a notification to us if there are any JavaScript files through Telegram. And of course you need to provide the token and API key for Telegram, which you could easily find how to do on the GitHub page for the tool itself. So what you could do is provide JSMon as a cron job to run maybe daily or whatever interval that might suit you, and check for those JavaScript files, and if there are any changes, it will directly notify you on your Telegram. So that way you could easily try to continuously run your automation for monitoring any changes in the JavaScript file. And of course the instructions for the same are also provided in the GitHub page for JSMon, so check that out for yourself. But this is just so that you know this technique exists and you could explore more into this. So this was it for today, guys. I hope you learned something from this video, and I hope I provided you with decent information for you to get interested or dig further into these techniques for your own self. And of course, if you find anything new or if you discover anything new or any new technique or something like that which might help people, please feel free to leave that in the comments down below for me personally and for others to learn as well. Thank you so much for watching, guys. Stay safe, keep hacking, and I'll see you in the next one.